Hi, welcome to a new video on TroubleTelevision. My name is Will. Today we are going to look a little bit in the Go code since I'm a Go engineer by day. Today we are going to write a simple file server that you can use for your development needs if you just develop a static page or a JavaScript site that you just want to basically run on a server, or for your production needs as well, because it should be possible to use this there as well. Okay, so we start out here with a simple HTTP listen and serve. This is actually a package function from the HTTP standard lib from Go. This will run the servMux, the default servMux as a server, so you can access it. Arguments are the address you actually want to expose the server on. And secondly, you can provide a handler if you, for example, don't want to use the default servMux but want to implement your own. You can provide it there through like a simplified interface where you just pass in a handler, basically. I added here a lookup env. This actually allows us to set the address that we have like as a default on 8080 as a environment variable and override it. So we have like some flexibility if when we have like the build binary. We add a log here in line 17 to actually see where the server started on. And then we add the simple handler for like the file server, also like for an HTTP standard lib. This actually, like the http.endl, will register a route on the default servMux. So we stick with the default implementations here because we don't really have like a special need. And the file server actually requires a directory input, which is like the root system where it should look for files. We use here like the CVD, like the current working directory. So we get this from the operating system as well. And we also allow to override that by another env variable called dir. So this is what you see here, which is basically the same procedure as with the port. We basically have a default which is like the working directory you're currently in, but you can override it with the dir env. Now we extend the listen on log, so we actually see where we are pointing to, and then we add a default like simple test file to test the server, and as you can see, it works. Because I'm a big fan of access logs, because then I actually see what people request or I request on my server. I want to show you here something special a little bit. So I extend the listen and serve call by a handler. We use handler func here, which accepts an argument, a simple handler function, and returns a type of handler. And in there, we actually do what handle or listen and serve does underneath. If there is no handler provided, we call on the default servMux serve HTTP, which is like the default for the handler. And now, since we want to have in the access log actually the response code as well, we need to do some magic here. We actually write a type that wraps the default response writer and writes the response code to, or the status code when you access it, to a struct variable that we can use later. So here you replace the wrapped writer in the call with our own, and then we actually have the possibility to add a defer function, which will print our access log after all the serving is done. And in this access log now, we have, since we have like proper lexical closure, the availability to access the status code from our wrapped writer. So we can put it in the logs. And we add also like a little timing here, so we know how long a request took, just to basically show how defer works. Oh. Then we start the server again. As you can see, we can still reach the document, and now we have actually access logs. And for 404 pages, like for not found documents, we have the same. All right, that's it. Thank you for watching.